The Big Bang theory is the prevailing cosmological model that explains the origin of the universe. It states that the universe began as an incredibly hot and dense state around 13.8 billion years ago, and has been expanding and cooling ever since. However, the question of what existed before the Big Bang is a subject of much debate and speculation among scientists and cosmologists. The concept of time as we understand it breaks down at the singularity of the Big Bang, so it is difficult to say what before could even mean in this context. Some theories propose the idea of a multiverse, in which our universe is just one of an infinite number of universes that exist, and that the Big Bang was the beginning of our universe, but not of all universes. Others propose that the universe has always existed and goes through an infinite cycle of expansion and contraction, but there is no scientific evidence to support this. The universe has not existed forever. It was born. Around 13.82 billion years ago, matter, energy, space, and time erupted into being in a fireball called the Big Bang. It expanded and, from the cooling debris, there congealed galaxies, islands of stars of which our Milky Way is one among about 2 trillion. This is the Big Bang theory. A universe popping into existence out of nothing is so bonkers that scientists had to be dragged kicking and screaming to the idea. But the evidence is compelling. The galaxies are flying apart like pieces of cosmic shrapnel. And the heat of the Big Bang is still around us. Greatly cooled by cosmic expansion, this afterglow appears not as visible light but principally as microwave radiation, the cosmic background radiation, which was discovered by radio astronomers in 1965. In the Big Bang, there was no center and no pre-existing void, so it didn't happen at any location. Space itself popped into existence and began expanding everywhere at once. As the cake grows, raisins recede from each other, with no center of expansion, just like the Big Bang. In the beginning of the Big Bang, there was the inflationary vacuum. When it doubled its volume, it doubled its energy. When it tripled its volume, it tripled its energy. If banknotes were like this and you pulled apart a stack, ever more would appear. Physicists call inflation the ultimate free lunch. The inflationary vacuum expanded ever faster. But it was a quantum thing. And quantum things are fundamentally unpredictable. Randomly, all over the inflationary vacuum, parts of it decayed into ordinary, everyday vacuum. Think of tiny bubbles forming in a vast ocean. In each bubble, the inflationary vacuum disappeared, but its enormous energy had to go somewhere. It went into creating matter and heating it. It went into creating a Big Bang. Our Big Bang universe is merely one such bubble among a possible infinity of other Big Bang universes in the ever-expanding inflationary vacuum. To start all this, a chunk of inflationary vacuum of only a kilogram was needed. Incredibly, the laws of quantum theory permit this to pop into existence out of nothing. The twin pillars of modern physics are Einstein's general relativity and quantum theory. The former reigns supreme in the large-scale universe, while the latter orchestrates the small-scale world of atoms and their constituents. They have resisted a merger, which is a problem because, in the Big Bang, the universe was small. To understand how it emerged, it is essential to unite Einstein's theory with quantum theory. The best candidate is string theory, which views the basic building blocks of reality as tiny strings of mass energy vibrating in 10-dimensional space-time. Only if we obtain such a theory will we be able to answer the ultimate questions: what is space? What is time? What is the universe? And where did it come from?